Everyone, welcome back, and today let's solve Leetcode problem 3100 titled Water Bottles Part 2. So just to kind of quickly summarize what this problem statement is really asking, effectively we're given two integers num bottles, which is the number of full water bottles that we initially start with, and we're also given an integer num exchange, which is the initial number of empty bottles that we need to exchange for one full bottle. And we can perform these operations in kind of two different ways. So the first way would be to drink any number of full water bottles and turn them into empty water bottles. And the second way would be to exchange the num exchange value of empty bottles for one full water bottle and then increase that num exchange value by 1. And the key constraint, or rather the key constraint here to really kind of keep track of here is that we cannot actually exchange multiple batches of empty bottles at once, and we have to return the maximum number of water bottles that we can actually drink. So let's go ahead and look at how these examples kind of pan out here, just to quickly kind of summarize and gloss over them. Num bottles is equal to 13. Again, this is just the number of full water bottles that we start with, so we have 13 full water bottles, and num exchange is 6. Basically, that means that's the initial number of empty bottles that we have to exchange for one full bottle. And again, we have 13 full bottles here. And our output in this case is 15. Why is it 15? Well, because that is the maximum number of water bottles that we can drink here, right? And to kind of just give us a kind of quick summary of how that would work. Initially, we'd have 13 full bottles, 0 empty bottles, num exchange is 0, and we of course drank 0 water bottles initially, and after we drink all 13 bottles, the, of course, full bottles would drop down to 0, their empty bottles would go all the way up to 13, num exchange would remain 6, and the bottles drunk in this case would be 13. And we kind of just continue this process until there's 1 bottle left, there's 2, and we just keep exchanging until finally we actually get a value of 15, as you see in the bottles drunk column. Right? In example 2, applying very similar logic here, it's 13, right? Basically, again, kind of just to summarize, this table shows the number of full water bottles, the number of empty water bottles, the value of an exchange, and the number of bottles drunk at each kind of step of this process here, right? And effectively, this last value, and this last kind of cell here in the bottom right kind of cell value, that's going to be our answer for the number of bottles drunk at the end. Right, so for the constraints here, we see that the number of bottles and our num exchange value are both going to be between 1 and 100, which leads us to the main observations that we can really make to solve this problem. And that is that this really is a very straightforward simulation problem. The way that it's structured and the way the problem wants us to solve this problem, there is nothing, very complex. It's a very straightforward, just take what the problem statement says and apply it in code, or just kind of simulate the situation in code here, right? Effectively, we just need to simulate the drinking and the exchanging process step by step, as we saw in the examples here, with each kind of step denoting a different action, which changes the number of full bottles we have, the bottles that we drunk, and our num exchange value as well, right? And of course, the main thing is we can't jump ahead or do multiple exchanges at once. We have to go step by step and simulate that process for each step individually, kind of just how the examples pan it out as well, just in this case in code, right? And the main kind of way to do that, of course, as you may have guessed, is a while loop here until we actually finish our main process. And again, the key insight here, tying back to that main observation, is that every time we actually perform an exchange, we know that the cost of it is going to increase. And so the first exchange would cost simply just num exchange empty bottles. The second cost would be num exchange plus 1, and the third one would cost num exchange plus 2, and so on and so forth. And I assume you get the idea. And the final kind of an important observation that we have to make is that we have to actually keep exchanging these water bottles as long as we actually have enough empty bottles to meet the current exchange requirement, right? That's kind of how the problem statement is really structured. So how are we going to kind of structure our actual algorithm and solution? Effectively, this is kind of called something like a greedy simulation approach, or at least that's what I'm going to call it for this video, where effectively we just start by drinking all the initial full bottles, and then we actually start keeping track of how many empty bottles we have for each step. And while we actually have enough empty bottles to make an exchange, we'll exchange empty bottles for a new full bottle. We'll then drink that bottle and increase the exchange cost by 1 by that specific amount, as you saw, right? And effectively, we simply just return the total bottles drunk at the end once the while loop kind of executes and it terminates, right? Which brings us to the main kind of solution here, where the code really isn't complex. Like I said it before, it is just a very direct, easy, simple simulation problem. We're only going to be using a few variables and kind of a few loops and iterations here, right? So the first thing that I'm going to do is actually initialize my answer, which is what I'm going to return. And of course, it's going to start off initially to num bottles, our initial input, as the number of full water bottles. And the reason why is because we're going to drink all of the initial bottles right away, like immediately once the kind of code starts, right? And that's basically our starting count, and we're going to add to it as we actually exchange and drink more bottles step by step in the process. And we're also going to initialize something called empty. This is just the kind of empty bottles here, and this is going to be, of course, num bottles as well. Oops. And the reason why is because we now have that many empty bottles after drinking all the initial bottles. And this variable is going to do nothing but track our currency for making those exchanges. Now, while our empty kind of exchange currency, if you will, or value, is less, or rather greater than or equal to our num exchange value, that basically means this is kind of like our main loop, our kind of validating condition, or our validating loop, if you will, while empty is greater than or equal to num exchange, which basically just means we're going to continue this loop and this process step by step as long as we have enough empty bottles to afford an exchange. And once empty actually drops below num exchange, meaning it's no longer greater than or equal to num exchange, that means we can't make any more exchanges, and we have to stop this while loop and just kind of return our final answer as the number of total bottles drunk. Now, what we're going to do is actually perform the exchange in each iteration. So I'm going to take empty and decrement it by our num exchange value to whatever value that is in this specific iteration. We're simply just performing this exchange, and we're giving up the num exchange empty bottles, num exchange being whatever value it is in this specific iteration. And that just does nothing but decrease our empty bottle count by exactly whatever the exchange count is, and we're doing that in each iteration every time we're kind of valid or we're allowed to make that exchange. And once we do that, of course, we have to then increment empty by 1, because from the exchange that we actually get from that kind of bottle exchange, we're going to get 1 full bottle, and we then immediately drink it, right? Because that's exactly what the problem says. That's kind of what the problem operations kind of were, if you kind of read through them yourself as well. Although I also kind of described them, if you recall correctly, right? So once we actually decrement it from empty, we're then going to increment empty by 1 because we got 1 more full bottle from that exchange, right? However, what's also important is that we immediately drink it, because that's exactly what the problem said. And once we actually immediately drink it, that becomes an empty bottle, and so we have to then add 1 to our empty bottle count, which is the whole point of why we're adding empty, why we're adding 1 to this empty count, right? And let's just kind of think about how that really works, right? Basically, kind of steps 5 and 6 really together mean that we have a net loss of num exchange minus 1 empty bottles per exchange cycle, and that's kind of another very important kind of insight to make, right? Our net loss is going to be num exchange minus 1 empty bottles every time we actually perform an exchange operation in each iteration of this while loop, or in each cycle, if you will. Once we do that, we then have to increment our answer by 1, and the whole reason why is because we just drank 1 more bottle, right? That's the one that we just got from the exchange, and so we have to increment our total drunk count by 1 as well, because we just, of course, drank 1 more bottle from the one that we just got from our exchange. And finally, we're then going to kind of perform the most crucial part, if you ask me, of the solution, which is incrementing num exchange by 1. And I really hope I spelled that right. And the reason why we do that is because, again, after each exchange, the cost has to increase by 1. And the next exchange will require 1 more empty bottle than this specific one did in this specific iteration. And that's what actually eventually stops us from exchanging forever. That's what actually eventually brings us out of this while loop here once empty drops below num exchange, because eventually once you increment num exchange enough, it's going to be greater than empty, right? That's kind of the main understanding to kind of take from this, right? That's what makes this problem very unique, if you will, right? And finally, once this while loop is done executing, once it fully terminates, meaning empty is no longer at least greater than or equal to num exchange, we then return our answer, because that's what we have once we actually exit the loop. That's when we can actually no longer afford an exchange, and so we just return the total number of bottles that we drank so far at this specific iteration, right? Kind of like the summation of them, if you will, right? So unless I made the syntax 0, there should be accepted, and there should be a valid solution, and let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be. So on a high level, how are we really solving this problem? Effectively, kind of just to kind of simulate how this works, effectively, let me just start off with a quick example here. Let's just say that initially I had num bottles, or rather my inputs, if you will, initially were equal to 13. Kind of just going off the example 1, I believe. 13 and 6, yeah. 13, and let's just say num exchange, hope I spelled it right, num exchange is equal to 6. These are our 2 starting input values here. Now the initial state, in fact, the initial state here is basically just going to be whatever our input values are, and we start off from there. So in the initial state, the first thing that we do, like we discussed in the problem example as well, is that we initially drink all 13 bottles initially. So answer would be 13. Empty would also hence be 13. Let me delete that period real quick. And num exchange would of course remain 6. We're not really changing that in this iteration quite yet, right? Now, in the actual first iteration, after we initially drink all the 13 bottles, that's when we actually start performing based on the value that we just computed. Now, in this first iteration, we know we have 13 empty bottles, and we need 6 for an exchange. And so we'd exchange 6 empty bottles to get 1 full bottle, and then immediately drink that full bottle that we just got from that exchange, right? So the way we kind of edit that, in fact, let me just call it iteration 1. The way we kind of edit that is that empty would now change from 13 minus the 6 that we had from the exchange, and we'd add 1 because we immediately drank it, right, that full bottle, which would give us a value of 8. Answer would now be incremented by 1, so it'd be equal to 14. Oops. And finally, we have to increment our num exchange value by 1 as well, like we do in each iteration. So num exchange would be 6 plus 1, or 7. And we'd keep doing this in every single iteration until we don't have enough bottles to kind of use for each exchange. So I believe it'd be iteration 3. We'd have 2 empty bottles in that iteration, and num exchange would be 8. Of course, 2 is not greater than or equal to 8, and so we can't exchange anymore. We'd exit out of the while loop, and that's when we return answer. And at that point, answer would be equal to 15. Right? That's kind of the main observation here. We have to really notice how the exchange cost increases, and that's what naturally terminates our process. And without actually increasing that cost, we really could just potentially be exchanging forever, or until we really just reach a 0 or 1 empty bottle. Right, so which brings us to the final kind of part of this video here, which is the actual complexity of this solution. So the overall runtime complexity here is actually going to be big O of n to the power of 1/2, or really big O of square root of n. Now, you can simplify that to just be big O of n, but, I think it's better to put it in big O of square root of n, and let's just see what Leetcode wants to do. So Leetcode just puts it in big O of n. More formally, technically it's big O of square root of n, but really that just simplifies to big O of n. It is a linear solution. And the reason why is because we know that the number of iterations depends on how many times we actually perform exchanges, basically just how long this while loop actually runs. And we know that each exchange is going to reduce our empty bottles by num exchange minus 1. And we also know that num exchange is going to increase by 1 each time. And so really in the worst case, kind of our bottleneck solution, we're essentially solving how many times can we actually subtract an arithmetic sequence k, k plus 1, k plus 2 from our input n. And the sum of an arithmetic sequence is really approximately quadratic, and so really if we perform m exchanges, it's approximately going to use up m squared bottles, and so m is going to be equal to the square root of n, giving us also big O of square root n iterations, which is also our runtime complexity. And another way to kind of reword that is that after actually we perform m exchanges, we've consumed approximately kind of m squared over 2 plus num exchange times n kind of overall operations, if you will. But really it's going to be approximately m equals big O of the square root of num bottles, which is really just big O of n, or a linear solution, right? Which brings us to the memory or space complexity. Believe it or not, this is actually going to be a big O of 1, or a constant memory or space complexity. Notice how we're not actually using any auxiliary memory, we're not using any extra data structures here, we're only using a fixed number of variable, more specifically integers, like answer and empty and num bottles, as we saw in the input. We're not actually using any auxiliary memory, and so this is not going to grow linearly with the input. It is constant space, or big O of 1, which is really just the most optimal space complexity we can have. We really can't do better than constant space for generally any problem, including this one as well, of course, right? So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.